Hello friends, my name is Pooja Arora and I am giving you video lectures on the subject of discrete mathematics, and we were discussing about graph theory. In my last video lecture, I have discussed some basic type of graph, weighted graph, null graph, and these basic graph I have included in my last video lecture. And my today's topic is bipartite graph. So let me explain what is bipartite graph. It is also called bigraph. And look, as the name suggests, bipartite, that means bipartitioned. So the definition is related to some partitioning of the graph. So what is the definition says? A graph whose vertices can be divided into two non-empty and disjoint set. Let's see what is it is saying. So if I have a graph, and in the graph I have total v number of vertices. So if I can divide these total number of vertices into two sets, set U and set V. The set should be non-empty and disjoint. So either set should not be an empty set. There must be a single vertex should be in the set, and these two sets should be disjoint sets. So there should be no common element. That means a vertex can be either in this set or in this set. A vertex cannot be in both of the sets. So if I can divide the total number of vertices in these two type of set such that every edge either connect a vertex from U to V or connect a vertex from V to U, means there can be a edge connecting the vertex from U to V or V to U, but there cannot be any edge which connect the vertices in the same set. Let's take an example and it will be more easy to understand. For example, I am making a graph. So this is a graph. I am naming the vertices V1, V2, V3, V4 and V5. Now let's see, this is a graph with 5 vertices. I have total number of vertices are 5. What I have to do, I have to divide these 5 vertices into two sets. So if I divide it this way, this is my first set U and this is my second set V. In my first set, I have 3 vertices V1, V3 and V5. In my second set V, I have 2 vertices V2 and V4. So what is the definition says that a graph whose vertices can be divided into two non-empty and disjoint sets. So these two sets are non-empty and these are also disjoint set, such that every edge connect a vertex from V to U or U to V. So there are the edges of the graph. This is my edge E1, this is my edge E2, this is my edge E3 and this is my edge E4. So there are 4 edges. Let's look at one by one. If I talk about the edge E1, it has the starting point in this set U, vertex V1, and ending point in set V2. So it connect V1 from V2. A vertex from set U connect from a vertex from set V. So secondly, if I see the edge E2, starting point in set U, ending point in set V. Same like E3, starting point in this set, ending point in this set. So I can see the definition in this way also, that the edges of the graph have the starting point in one set and ending vertex in the another set. But we can look the definition in the another way also. There should not be any edge connecting these vertices. I mean, the vertex in the same set should not be connected. That means there should be no any edge between V1 and V3. In other words, we can also say that vertex in the same set should not be adjacent vertex. What are adjacent vertex? Adjacent vertex are vertex which are directly connected with an edge. So V1 and V2 are adjacent vertex and both are in different set. But V1 and V3 cannot be adjacent because there should be no edge connecting V1 to V3 in bipartite graph. Okay, let's take one more example to understand the concept. If I draw like this, and I'm naming V1, V2, V3, V4, V5 and V6, and I will try that if I can make two sets of the vertex. So there are total 6 vertices and I am making two sets of them. So I start with the vertex V1. V1 is connecting to V2 and V3. So V2 and V3 must be in another set. So I am writing them here, V2 and V3. So this is the basic way to start bipartite graph. Start with one vertex and the adjacent vertex put it in the another set. So I am putting V2 and V3 in the another set. Now look at this V2. V2 is connecting to V1 and V4. So I am putting V4 in this set. Okay, because V2 is connecting to V1 is connecting to V2, V1 is connecting to V3. Now V2 is connecting to V4 and V3 is connecting to V5. V3 is connecting to V5 and what's the vertex left is V6. V5 is connecting to V6. So I write it here. So in this way, I divide the total number of vertices in two sets. The first set includes the vertex V1, V4, V5 and V2, V3, V6. This is my set U and this is my set V. So every edge in the graph, if I name the vertex edges E1, E2, E3, E4 and E5. So you can see that edge E1 is connecting vertex V1 and V2. V1 and V2 are both in opposite set in a different set. So this type of graph is called bipartite graph. You can see it easily that this vertex in the same set V1, V4 and V5 are not connected. V1 is not connected to V4. V1 is not connected to V5 directly. And vertex V2, V3 and V6 are not directly connected. Vertex V2 and V3 are not directly connected. V2 and V6 are not directly connected. V3 and V6 are not directly connected. So this is an example of bipartite graph. So you can understand the example in another way also. If I talk about the coloring of the graph, we can say that a graph is a bipartite graph if it can be colored with two colors. For example, what I am saying is if I colored the vertices with the red one. Well, I hope you know the basic concept of graph coloring. Adjacent vertex cannot be colored with the same vertex. That means if I am coloring the V1 with red color, I cannot color V2 and V3 the same red. So I have to change my color. So what I do, I color V2 as blue and I color V3 again blue, because these two are not adjacent. V1 is adjacent to both of them, so I cannot use red for both of them. I am using blue for both of them. Now I colored V2 as blue color, so I cannot color it with blue. So I am using red again, because red is not adjacent to V4 anyway. And V3 is also blue, so I am coloring V5 as red and again V6 as blue. So I colored my whole graph with only two colors, red and blue. So this is called a bipartite graph if it can be colored with two colors. If I can color whole graph with only using two colors, then the graph is a bipartite graph. I can make a point here that every acyclic graph, if I talk about a cyclic graph, is bipartite because it can be colored with two colors. And if there is a cycle graph, it will be either with even vertex or odd vertex. So there is a cycle graph. If it has even number of vertex, then it is a bipartite graph. But if it has odd number of vertices, it is not a bipartite graph. Let's take an example of a cycle graph. You can note this example if you want to. Okay. So I am making a simple graph with 4 vertices, V1, V2, V3 and V4. So this is a simple cyclic graph with 4 vertices. I am just drawing a simple square or a rectangle with 4 vertices. And let's look, it is a bipartite graph or not. Okay, listen. If I draw this sets like this, we can determine that this is not a bipartite graph because vertex in the same set are connecting. But this is not always the case. You can do it in another way also. V1, V2, V3 and V4. This was my graph and I'm just changing the way I look at the graph. What I am doing is V1, V3, V2 and V4. I am not changing the connectivity. The vertex V1 is connecting to V2 and V4. The vertex V1 is connecting to V2 and V4. The vertex V3 is connecting to V2 and V4. V3 is connecting to V2 and V4. So these two are the same graph. It is just like I twist the rectangle. I found this graph. So this is the same. What I can do, I can make a set of vertex V1 and V3 and another set of V2 and V4. Now you can see that there is an edge connecting this vertex to this vertex from set U to set V, but there is no such as connecting V1 and V3 and there is no such as connecting V2 and V4. So this is a bipartite graph. You can see it as a graph coloring example also. If I color it red, I cannot color this red, I cannot color this red. So I color this blue and I color this also blue and again I color with red. So with two color I can color my whole graph. So I can see that this is example of bipartite graph. This is a cyclic graph with even number of vertices. There are total number of 4 vertices. So this is a even cyclic graph. So it is a bipartite graph. But if I take an example of odd cyclic graph, that means 1, 2, 3, 4 and 5. This is an odd cyclic graph. Vertex V1, V2, V3, V4 and V5. So this is not a bipartite graph because we cannot divide the vertices into 2 sets such that 2 sets are disjoint. Because if I use the coloring theorem, then if I color this red, I should color blue and blue. Now this is blue, so I must color with red color, and this is blue, so I must color with red color. So these 2 adjacent vertices cannot be colored with same color. So I have to change it. That means I have to use the third color here. I cannot color the whole graph with 2 colors. So this is not a bipartite graph. So here I explain the concept of bipartite graph. Simply 2 points only. That you have to divide the vertex into 2 sets. Both sets should be non-empty. Both sets should be disjoint. And every edge should connect a vertex from one set to another set. But the vertex in the same set should not be connected. Just relate it with the name by partition the vertex and edges between the partition, not in the same set. Then you can get the bipartite graph. Okay. Thank you for watching my video.